Multiplying fractions. You can use folding to show a fractional part of a fraction. You will need a set of fraction pieces. Here's how to find 1/2 of 1/3. Use the 1/3 fraction piece. Fold it in half. Compare the folded part with the other fraction pieces to find a piece that matches. Here, we see 1/2 of 1/3 is 1/6. Here's 1, this whole box. Here's 1/3, which is 1/3 of the box. And you can see that 1/2 of this box is the same size as one piece in a 6. So 1, 2, 3, 4, 5, 6 pieces make up the whole. Therefore, 1/2 of 1/3 is the same as 1/6. You can use shading to find a fractional part of another fraction. Here's how to find 1/3 of 1/4. First, we're going to divide our whole into fourths. So first I'll divide it in half. That's a bad line. First I'll divide it in half, and then in half again. So there's 4 pieces. Now we're going to shade 1/3 of 1/4. So here's 1/4. I'll divide this one piece into thirds. So there's 3 pieces now in this 1/4, and this is going to be 1/3 of 1/4. So the fourth is here, and the third is here. 1/3 of 1/4. So, what fractional part of the whole did you shade? Well, 1/12. Because if we continued breaking this up, where each piece here is in thirds, you can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 portions total in the whole, and we shaded one little piece, so 1/12. Label the points on the number line that correspond to these fractions. Alright, so we have our whole here. This is 1. So this piece right here marks where 1/6 is. This is 2/6. This is 3/6. This is 4/6. And this is 5/6. And this is 6/6, which is 1. And you can see that 3/6 is half, if you were to simplify. You're then going to carefully cut out a strip of paper that has a length of 5/6. Bring the ends of the strip together to fold the strip of paper in half. How long is half of the strip? Use your strip to mark this point on the number line. Alright, so if we had a piece of paper that was this long, from here to here, so imagine this was cut off, and then we were to cut this in half. So you were to fold this in half, that would be right here. That's the halfway point between here and here. So this is 1, 2.5, 2.5 pieces long. So if we were, instead of 1/6, if we were instead looking at twelfths, it would be 1, 2, 3, 4, 5 twelfths. Unfold your paper strip so that you start with 5/6 again. Now fold the strip of paper in half, then in half again. How long is half of the strip? Alright, so that's saying, let's remove this. So we have now a strip of paper that is half of 5/6. So it's from here to here. So the whole piece of paper is here to here. And we want to know what half of this is. Well, that would be there. So we have 1, 2.5 pieces that are each 1/12. So 1/12, 2/12, 2.5 twelfths. Well, maybe if we instead looked at 24ths, we would see that it's 5 24ths. And that is how long half of 5/6 is. Multiplication describes events when equal groups of things are combined together. For example, 3 groups of 4 apples can be abbreviated using the number sentence 3 times 4 equals 12. There's 12 apples. Multiplication number sentences should be read as, what is variable groups of variable things? The variable can be a whole number, a rational number, or any expression that represents either a number of groups or the number of items in a group. We will be working with variables that are fractions. Read this number sentence aloud using the phrase, what is 1/3 groups of 2/5 things? Multiplication of two factors can be illustrated using an array called an area model. When you make an array, each factor represents either the vertical or horizontal dimension of a square or rectangle. With the above example, a rectangle can be constructed with 3 units on one side and 4 units on the other side. The resulting 3x4 rectangle contains 12 square units. The result can be read, 12 is 3 groups of 4. The array or area model is also very effective when illustrating multiplication of two fractions. When multiplying half by 5/4, the question can be read, what is 1/2 of 5/4? Or, what is 1/2 of a group of 5/4? Let's show a group of 5/4. Here is 4/4 plus 1/4, which gives us 5/4. And all we do down here is cut it in half this way, and we show 1/2 of these, which gives us 1, 2, 3, 4, 5/8, because now we're looking at a whole that is divided up into 8 pieces. Fractions, multiply the numerators and then multiply the denominators. Make sure you simplify your answer. So 4/5 times 3/4 gives us 4 times 3 on top and 5 times 4 on the bottom, which is 12 divided by 20. If you divide the top and the bottom by 4, we get 3/5 as our answer. Sketch an area model to check our answer. All right, so we begin with 4/5. So we draw fifths. 2, 3, 4. So here are 5/5, but we only want 4 of those fifths. So I will color in 4 of the 5 pieces. All right, and now we want 3/4 of that. So we will divide this in fourths horizontally. All right, and we want 3/4 of these. So we have 1, 2, 3. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of these out of 20 total, because there's 20 boxes in this entire thing now. So 12 over 20, when simplified, becomes 3/5. Examples. Sketch an area model to check your answer. 7/11 times 2/9. 7 times 2 is 14. 11 times 9 is 99. So I went ahead and drew this. So let's fill it in. 7/11. So there's 11 pieces this way. So we can color in 1, 2, 3, 4, 5, 6, 7. And now we want 2/9. So we can take the top 2 of these and color those in. All right, and that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces out of the 99 total pieces, because there's 11 pieces on this end and there's 9 pieces here, so there's 99 total boxes, so this is correct. All right, moving on. Cover this up there. We'll leave it open. 3/8 times 4/9. 3 times 4 gives us 12. 8 times 9 gives us 72. If you divide the top and the bottom by 6, you end up with 1/6. So here's our box. We have 8 pieces on this side, and we have 9 pieces this way. So we're going to begin by coloring in 3/8. So that's 1, 2, 3. And then we can come in and get 4/9. So 1, 2, 3, 4. So that is a total of 12 boxes out of 72 total boxes. And if you see this, you can also see that if you were to divide this box into 6 pieces, like one, well, not like that, like this and this, and like that. See how now there's like 6 giant chunks like this? You can see that this fills in about 1/6, so that's correct. Move on, 8/14 times 6/7. 8 times 6 gives us 48. 14 times 7 gives us 98. If you were to reduce, you get 24 over 49, but let's look at the drawing. All right, so 8 out of 14. I ended up reducing this fraction first so that it would make this a little less unruly. So I divided the top and bottom by 2, and I got 4/7. So I made this box for 4/7 times 6/7 so that it wasn't too crazy. First we will do, so this is 7 by 7, so 49. So basically I simplified at the beginning when I was doing this drawing instead of at the end. Alright, so we have 4/7, so 1, 2, 3, 4, and then we have 6/7, 1, 2, 3, 4, 5, 6. And if you were to count up all of these boxes that have green and blue lines, you would get 24 of them.